Welcome to our webinar about developer experience for embedded systems engineering. Nice to have you here. As first part of our introduction, I want to give you a short overview of the agenda. We will talk about development processes and its challenges, but also about the resulting goals for improvement. As next step, we will explore a DevEx Platform architecture and how it can improve your developer experience. An example says more than 1,000 words. So we will show you the usage for an embedded software use case. As second part of our introduction, we want to tell you a little bit more about us. My name is Cornelia Voike and I'm Senior Embedded Solution Architect at Demicon. My expertise covers traditional, safety-critical, agile, team-based and autonomous software development for embedded systems. It also includes hardware-related architecture and tasks as well as IoT and cloud integration. Regarding all topics around cloud platforms, I'm happy to have my colleague Abdul here.
Thank you very much, Cornelia. Hello everyone, my name is Abdul Wahid. I'm a senior DevOps engineer at Demicon. I have around 5 years of experience in various cloud technologies like AWS and Azure. My expertise includes working with CI/CD pipelines, writing infrastructure as code, orchestrating microservices, observability of applications, cost optimization, and much more.
Let's start with a key question. What exactly means developer experience? Developer experience means the sum of all elements that affect the environment in which developers work. This includes, of course, available software tools and hardware equipment required for development, as well as the IT infrastructure, any kind of processes and workflows, and even elements like the team structure and company atmosphere. The easiest way to get an idea about real-life developer experiences is to ask the following question. Do you remember a typical development process of the past? The longer I thought about this question, the more things came in my mind, and I suppose we share at least some of the following experiences. First, you have to define structures mostly based on the system architecture. You have to set up the build environment and perhaps the debug environment for evaluation hardware. Then developing starts, and at least versioning, but usually collaboration features to work in a team are required. This needs IT infrastructure and means either to create IT requests or to improvise on your own. At the latest, at a certain point, you need a build server and CI/CD pipelines for automation. This requires to integrate the build environment on the build server. This is usually followed by the implementation of test automation and requires again configuration and integration of toolchains, workflows, and additionally result evaluation. Finally, everything is running and you're happy that it works. Either the hardware will change, for example, to another prototype, or there will be more hardware variants. Both need software variant management, as well as extending the build and test environments. In parallel to all of this, development continues and complexity increases because of the growth or change of software components, workflows, team size, or even requirements. Within this process, it is not always easy to remember best practices, quality standards, and sufficient documentation. All in sum often led to the well-known stress before a release day. If you ever developed embedded software, you perhaps already have flashbacks. But anyway, we need to talk more about the challenges and pain points of embedded developers. By the way, all of this not only affects the developers, but also the project management, team leads, quality assurance, and even the resulting product. Not only at the beginning of a project, but also when it grows over time, you face the challenge of setting up things again and again. These things can be structures of source files, directories, shared information like datasheets, as well as technical documentation. Other things can be the configuration of build environments like Yocto, build tools like CMake, or test tools like Testwell CTC++. Or any tools, IDEs, or frameworks you need or want to use. Configuration of containerized builds, as well as specific build host setups, and the integration in CI/CD pipelines can also be one of these things. Followed by tasks like navigating through IoT and cloud server configurations, or creating very special setups to have access or enabling communication for development and testing purposes. Another field of possible challenges is the required infrastructure. For example, if you have to send requests or to create tickets for your IT department to get resources, or if you have to wait on any other colleague to get access. In the case that the build server configuration does not fit to your needs, it can also be challenging. This means missing access rights, missing connections, wrong tools, or any other misconfiguration. Additionally, if the server performance is not scalable or just not scaled, your jobs can be pending for a long time until they start. And you have to wait again until your pipeline run is completed. I still remember how it feels to have a single native build server within a team of 10 developers and a pipeline runtime of 8 hours. And the moment when you see that your pipeline run failed with a mysterious random error which only happens on the build server, this is not a funny moment, especially if you are also the maintainer of the test automation. Also, the collaboration in a team can bring some challenges. Perhaps you also know issues like if it only compiles and builds in your local environment, or the moment when you merge main with your branch and suddenly nothing works anymore, or if others didn't test their features and you have to fix it now. This is often followed by issues like missing dependencies and packages or version conflicts. Perhaps you also got to know how Yocto, build tools, or any other tools, or even your prepared scripts can be misused by others in many different ways. Of course, also missing documentation and a lack of quality can make collaboration as well as compliance with any standards difficult. Now I hand over to Abdul.
So now I would like to talk about some of the challenges that one could face being a DevOps engineer or cloud expert, but specifically related to embedded systems development. So for example, embedded developers want full access to be able to configure what they need, and in the process of doing so, they do insecure things like connecting unknown devices to the networks and build hosts, which is a lack of security during the development process. And similarly, talking about complexity, just a browser is not enough for the development process. There are various requirements like specific tools which needs to be licensed, or needing software package management, for example, integration of IDE tools in automation, which all can increase the complexity and effort. And when it comes to their pipelines really require a high performance computing power, or otherwise it would take too long for them, especially when building firmware images including Linux and a high count of software packages. This is additionally affected by lots of pipelines and especially the testing stages. The issues which I just talked about are just the tip of the iceberg. In reality, developers face a lot more issues when they work with embedded systems.
Now I want to ask you, which is your biggest development challenge? Knowing all challenges helps us to derive the goals to improve the developer experience. An essential goal is to support reusability of certain parts, or if required even of whole setups and environments. This also allows to reuse existing knowledge and technical solutions. Another goal is reproducibility, which means on one side that reusability should be applicable in an easy, reliable and standardized way, and on the other side that processes, software versions, tests and everything else during the development should be reproducibly usable. This leads us to the goal of providing access to best practices, which also stays in relation with the goals to ensure quality and security and to establish standardized processes. If compliance with standards is required, for example for safety-critical applications, it is an additional goal to enforce it. The goals regarding the infrastructure are to use self-services for independent but compliant provisioning of resources, ensuring required access and options for managing it, as well as providing sufficient performance. A goal from the viewpoint of IT, DevOps and cloud experts could be that embedded developers only use sandboxes for their development, build and testing within secure configurations. Additionally, scalable servers make it more easy to handle changing performance requirements, and lifecycle management, for example of build artifacts, can avoid data waste and high costs. Last but not least, it would be really great if there would be no way to compromise the IT security. Let us think about a bigger goal. Wouldn't it be nice if embedded developers could create required parts or a whole project infrastructure, including the development environment, only with a few clicks? This is what developer experience platforms can be used for. DevEx platforms provide templates-based automation for infrastructure and environments. Here you can see our full reference architecture of a developer experience platform. But don't be afraid. I only want to show that it is not a trivial small piece of software, but a powerful solution with different components providing many options for automation. That's what my great colleagues, including Abdul, are experts for. Now I will show you the architecture reduced to the parts and mechanisms which are important for embedded development. One of these parts is the DevEx Platform frontend for developers. It can be web-based, script-based, or accessible via command line, dependent on the developer's needs. Via this front-end, the related DevEx template is selected, and additional input is forwarded to the DevEx Platform backend. A DevEx template consists of several files and, if required, further resources, like template repositories or any other data which can be copied from somewhere or just be created. This allows a very flexible scope of the predefined content. The backend process then creates, configures, copies, or transfers any resources or triggers any existing tool or system you can access with an API. As a result, you get the infrastructure and the environments which are predefined by the DevEx template. This also allows to cover the full lifecycle, for example by structures and pipelines including everything required for development, build, testing, deployment and maintenance. Let's just have a closer look at the DevEx templates and how they can be used to realize whatever you need in the scope of applications, infrastructures, quality assurance, security compliance and observability. The flexible scope is provided by the DevEx Platform backend, which processes the templates. A template can be compared with a Yocto recipe or any other build tool configuration. It combines to use resources and the usage of tools and APIs to create what you need and where you need it. Resources can be located locally or externally and can provide source code files, scripts, configuration files, data structures, archives, repositories, virtual machines, and more. But it can also consist of information like user lists, access rights, or credentials. The usage of tools and APIs means either to create or to access IT infrastructure and configuring it. For example, it comfortably supports creating or cloning repositories with defined user access rights, which provides many additional features and possible combinations. It is possible to configure cloud services and to forward the credentials to the build pipeline, or you can provide pre-configured CI/CD pipelines, including different stages, workflows, and quality gates. And additionally, you can set up or configure project management and documentation tools like Jira and Confluence. As an example for embedded development, you can provide hardware-specific templates providing a full Yocto configuration and a build pipeline. The containerized build could use pre-built artifacts and already integrate the IoT application, including secret keys and certificates. Additionally, you could provide to execute tests on emulated hardware or even predefine the workflow for an update rollout. The scope and count of DevEx Platform templates are key factors for balancing effort and comfort. This means a template can be either a basic one, like an empty skeleton, or it can be complex when using many different resources and tools and providing full technical solutions, components, or environments. You can either use a template just to give a defined point to start or to extend your development, or you can predefine everything, from build configuration and project management up to the update rollout. Additionally, you can either provide a choice of templates, for example for certain components, or you can create a template of every small part of all solutions you ever developed, and even provide combinations of it, which could be selectable in the DevEx Platform frontend. The golden way for balancing and scaling the scope of DevEx templates and its usage depends on different parameters. One of these parameters is the probability of the usage, which means if you need to create and configure infrastructure or to reuse technical solutions, environments or workflows quite often, and if it is used by many developers. This is also tightly coupled with the quantity, which means if your templates provide a useful base with good quality, and if everything is working well. Further parameters are the requirements you could have, for example for quality, security and safety. If compliance with industrial standards is required, it could make sense that every created repository already provides a CI/CD pipeline with pre-configured test stages and quality gates. Of course, this can increase the complexity of the templates, and it always has to be analyzed if the preparation effort for a template is justified. The result of balancing and scaling should be that every template will be worth to be available. Now let's switch to our example use case. And my first question is if you can imagine a typical demo setup. My colleagues wished an example use case with Linux and using Yocto to build. Of course, it would be great if they could also play around with their own Raspberry Pis. And spoiler alarm, yes, they did. And they also tried to update my own Raspberry Pi via an IoT update rollout. This also leads us to the next points on the wish list: communication with AWS IoT services and using GitLab including CI/CD pipelines. My additional thoughts were that cast for the Yocto configuration would be very useful, and additionally, a containerized build with a pre-built Docker image as simplest representation of a build artifact. Transferred to our DevEx Platform architecture, this is the result. We use Backstage as a web-based front-end to select the right template and to enter some required information like the device fleet name. This will trigger a GitLab pipeline, which then proceeds using Terraform. We use a GitLab repository as an additional template resource, which provides the full pre-configured build environment and build pipeline. Within the DevEx process, the AWS IoT services are configured, which means that policies, certificates, the device group, and more are created. The certificate and some more information like the AWS endpoint are then forwarded to the GitLab project and added to the firmware during the build process. Using this firmware, the Raspberry Pi registers itself in the AWS IoT service and enables communication via MQTT. Now we want to demonstrate you how it looks and feels to use our DevEx platform. For this, I hand over to Abdul.
So now I will show you an example on how to use DevEx for embedded software development, but from the point of view of a developer. We'll start in the web front end using Backstage, and on the home page you can see a list of already deployed components. To create a new component, click on Create button, which is on the top right corner of the screen. There we can see a currently available list of the templates which we can choose from. We are going to choose the IoT embedded development one. Click on Choose. This leads us to the template-specific input page where we can enter the required information. We can enter the title like DevEx Embedded, for example. Additionally, we have to enter the unique name of the development environment, which will be used as the repository name, RPI IoT. I suggest to use a naming convention like, for example, a project or an application name, or whatever it needs to differ your development environments. Then we can optionally enter a more detailed description like Raspberry Pi for Yocto providing AWS IoT application, for example. And of course, we need to give a device fleet name, which will be used as AWS IoT device group name. I'm going to name it as DevEx. At the end, we need to choose an owner group to give defined access rights. I'm going to choose cloud engineering, for example, from the list. All these fields are customizable and are parts of the template. Once you are happy with your inputs, you can click on Review page. You can review all of the information if it's correct. And once you are satisfied, you can click on Create button. This will going to take a couple of seconds. And after some time, all of your templates are being deployed and are ready to be seen on the home page. So on the home page, you see a list of all the components. We are going to select the one which is created, which is DevEx Embedded. So let's just click on it. Here you can see all the details. There is an About section showing high-level overview of the component, a hierarchical relationship for group permissions, and links to our repositories, which are being created as part of the creation process of this component. Let's just go through these repositories. First, I'll open the service repository. This repository is the basis for the integration of standard embedded Linux firmware built in the DevEx. You can navigate into each directory or folder to explore more about its contents. Secondly, we have the live repository. This live repository manages various environments for embedded system services, and you can create more environments as you want. With this, I will conclude my demo. Thank you.